Hello mathematics students. In this tutorial we're going to look at questions based on graphs of polynomials. So in this question there's this polynomial p of x whose graph is given here, and we are supposed to comment on the following statements. The number of turning points. So that is easy. So there's a turn here, 1, 2, 3, 4, 5, 6 and 7. So there are 7 turning points. And then we are asked the number of roots. So roots would be where the polynomial touches or cuts the x-axis. So that is 1, 2, 3 and 4 and 5. So there are 5 distinct roots. Now what is the minimum possible degree? Minimum possible degree of this polynomial based on the number of roots. So the minimum possible degree would be the same as the number of roots. So if there are n roots to a polynomial, then it should have a degree of at least n. So 5 is the minimum possible degree of this polynomial based on the roots. But now they are asking what is the minimum possible degree based on the turning points. So here we see this thing, a straight line has no turning points, a quadratic equation has one turning point, and a cubic would have 2 turning points at most. Likewise, a quartic, that is a 4th degree polynomial, would have 3 turning points at most. So if you have n turning points, then the minimum possible degree of the polynomial would be n plus 1. So here that is 8. Now what would be the minimum degree of the polynomial given all the information we have? Then you know that it has to be at least 8. The 5, which is on the basis of the roots, is a lesser number than 8, and we know already that it has to be at least 8. So the minimum degree of the polynomial should be the greater of these two, which is 8, because 6 and 7 and 5 are not allowed on the basis of turning points. And then we are being asked what is the end behavior and the coefficient of the highest degree term. So the end behavior shows that the polynomial is coming from infinity and going to infinity, which means the degree of the polynomial is definitely even. So we can say that it's an even degree polynomial. So as you can see, we've just drawn these basic curves for the linear and quadratic and cubic and quartic polynomials. So linear, which is an odd degree polynomial, it comes from minus infinity and it goes to plus infinity. Whereas quadratic, a parabola, here it is coming from minus infinity and it is going to minus infinity. So when it's even degree, you see that the ends of the curves are in the same directions. Similarly, for the quartic, here this is coming from infinity and going to infinity. Whereas for a cubic, this is coming from minus infinity and going to plus infinity. So here this is coming from infinity and going to infinity. Therefore, this is a even degree polynomial. And the coefficient of the highest degree term. So the coefficient of the highest degree term determines whether the behavior of the polynomial as x increases, whether it is going to plus infinity or minus infinity. If the coefficient of the highest degree term is positive, it goes to plus infinity. So this is going to plus infinity. So this has to be positive coefficient for the highest degree